Hello students, let us continue the session on coordinate geometry. In the previous session, we had discussed exercise 7.1, which was all about distance formula. In today's session, we shall solve the questions of exercise 7.2, which is related to section formula. The first question here is to find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio 2:3. Let me consider the point P divides the line segment joining the point A, which is -1, 7 and B 4, -3 in the ratio 2:3. It means point P is somewhere on the line segment AB such that it is making the ratio 2:3. The coordinates of point A is -1, 7 and the coordinates of point B is 4, -3. We have learned the section formula. The coordinate of point P is given by m1x2 plus m2x1 divided by m1 plus m2, comma m1y2 plus m2y1 divided by m1 plus m2. Let us substitute the respective values. It is 2 multiplied to 4 plus 3 multiplied to -1 divided by 2 plus 3, comma 2 multiplied to -3 plus 3 multiplied to 7 divided by 2 plus 3. 2 into 4 is 8 plus of -3 will be 5. We get 5 by 5, comma 2 multiplied to -3 is -6, added to positive 21 will be 15, 15 upon 5. So the coordinates of the point P is 1, 3. Second question, find the coordinates of the points of trisection of the line segment joining 4, -1 and -2, -3. We should understand the meaning of trisection. Trisection refers to dividing into 3 equal parts. Suppose if I consider the line segment AB, where point A represents 4, -1 and point B represents -2, -3. Here there must be 2 points, then only there will be trisection and these parts will be equal. If I consider P and Q as the points of trisection of the line segment, it will be making 3 equal parts and the ratio of AP is to PB will be 1:2, AQ is to QB will be 2:1. Hope I have made it very clear. If I use AP is to PB, I get 1:2. The coordinates of the point P is given by, let me write the formula here, the section formula. The formula is, the x coordinate is m1x2 plus m2x1 divided by m1 plus m2. and y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2. These are the coordinates of the point which is dividing the line segment in the ratio m1 is to m2. With this formula, let me find the coordinates of point P. It will be 1 multiplied to negative 2 plus 2 multiplied to 4 divided by 1 plus 2. 1 multiplied to negative 3 plus 2 multiplied to negative 1 divided by 1 plus 2. This is nothing but minus 2 added to positive 8 will be 6 upon 3. Minus 3 and minus 2, when they are added, we get negative 5 by 3. So the coordinates of the point P will be 2, negative 5 by 3. In the same way, I need to find the coordinates of point Q. So I have to consider the ratio now. AQ is to QB. This will be 2 is to 1. So let me again make use of the same section formula. It will be 2 multiplied to negative 2 plus 1 multiplied to 4 divided by 2 plus 1, comma 2 multiplied to negative 3 plus 1 multiplied to negative 1 divided by 2 plus 1. 2 into minus 2 is negative 4, added to positive 4 becomes 0, so it is 0 upon 3, comma, this becomes minus 6 and there's one more minus 1. Sum becomes negative 7 upon 3. So the coordinates of Q will be 0, negative 7 upon 3. This is how we can find the points, coordinates of points making trisection of a given line segment. Question number 3. It's a lengthy question. To conduct sports day activities in a rectangular shaped school ground ABCD, lines have been drawn with chalk powder at distance of 1 meter each. 100 flower pots have been placed at a distance of 1 meter from each other along AD, as shown in figure 7.12. Niharika runs 1/4 the distance AD on the second line and posts a green flag. Preet runs 1/5 the distance AD on the 8th line and posts a red flag. What is the distance between both the flags? If Rashmi has to post a blue flag exactly halfway between the lines segment joining the two flags, where should post her flag? Here you need to make use of the coordinates with respect to the line. So let us take sentence by sentence. Here they have given that Niharika runs 1/4 the distance AD on the second line and posts a green flag. Therefore, the coordinates of the flag posted by Niharika, I'll represent with the letter N representing Niharikas. So it will be 2, 1 by 4 times of 100, because in total there are 100 flag parts. So the coordinate will be 2, 25. Preet runs 1/5 the distance AD on 8th line and posts a red flag Therefore, the coordinates of the flag posted by Preet will be, I'll represent this by letter P. It's a 8th line, so 8, 1/5 of total 100. So the coordinate will be 8, 20. Therefore, the distance between the two flags will be the distance NP. Using distance formula, I can find the distance between these two flags. It will be 8 minus 2 whole square plus 20 minus 25 whole square. 8 minus 2 will be 6 square is 36 plus root of 36 plus 25 will be root 61. If Rashmi has to post a blue flag exactly half the way between the line segment joining these two flags, then the coordinates of the flag posted by Rashmi will be the coordinates of the midpoint of NP. Coordinates of flag posted by Rashmi will be equal to midpoint. So I need to add them and divide by 2. I'll call with the letter R. Midpoint formula is x1 plus x2 divided by 2. So it is 8 plus 2 plus 8 divided by 2, 25 plus 20 divided by 2. This will be equal to 5, 45 by 2. Therefore, Rashmi should post the flag on the 5th line. Here 5 represents the 5th line, and at a distance 22.5 meters. 45 by 2 is 22.5 meters. So we can mention that it's the 5th line at 22.5 meter distance. This will be the 5th line and 22.5 meters. Question number 4. Find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by -1, 6. They haven't given the ratio. We need to find the ratio. So for convenience, I'll take the ratio as something like k:1. Let the point P -1, 6 divides the line segment joining A -3, 10 and B 6, -8 in the ratio k:1. So it means that there's a line segment AB and there's a point P. The coordinate is -1, +6. Coordinate of B is 6, -8. Coordinate of A is -3, 10, and it is dividing in the ratio k:1. Now using the section formula, I have P -1, 6 will be equal to k times 6 plus 1 multiplied to -3 divided by k plus 1, comma k multiplied to -8 plus 1 multiplied to 10 divided by k plus 1. Now I need to simplify this. So the coordinate of point P is -1, 6, which is equal to, on simplification we get 6k minus 3 divided by k plus 1, comma -8k plus 10 divided by k plus 1. Now I need to equate it. This implies that 6k minus 3 divided by k plus 1 is -1 and -8k plus 10 divided by k plus 1 is +6. Here we get 6k minus 3 equal to -k minus 1. So on simplification we get 7 times k equal to +3 minus 2, which is 2. So the value of k is 2/7. Therefore the required ratio k:1 is same as 2:7. 2/7:1 is same as 2:7. Question number 5. Find the ratio in which the line segment joining A 1, -5 and B -4, 5 is divided by x-axis. Also find the coordinates of point of division. So here they have not given the ratio and they have just mentioned that it is exactly on x-axis. So let the line joining a line segment joining A 1, -5 and B -4, 5 is divided by x-axis at point, I'll just mention as point P. So the coordinate will be 0, x, 0. The reason is it is divided by the x-axis into k:1. I have taken the ratio as k:1. It means there's a point A which is 1, -5 and there's point B which is -4, 5. It is divided by a point P x, 0 in the ratio k:1. So by using section formula, I have the coordinate point P x, 0 will be equal to k multiplied to -4 plus 1 into 1 divided by k plus 1 comma k multiplied to 5 plus 1 multiplied to negative 5 divided by k plus 1 is same as negative 4k plus 1 divided by k plus 1 comma 5k minus 5 divided by k plus 1. Now this can be equated here. This implies minus 4k plus 1 divided by k plus 1 will be equal to x, and 5k minus 5 divided by k plus 1 will be equal to 0. Now if I consider this part, I'll be having 5k minus 5 will be equal to 0. This implies the value of k is 1. Placing k is equal to 1 in the equation minus 4k plus 1 divided by k plus 1 equal to x, we get minus 4 plus 1 divided by 1 plus 1, which is equal to x. So x value will be negative 3 by 2. Therefore, coordinate of the point P x comma 0 will be negative 3 by 2 comma 0, and is dividing AB in the ratio 1:1. So we have found the coordinate of the point as well as the ratio in which it is dividing the line segment AB. Question number 6. If 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find the value of x, y. Here, if I have a parallelogram, let this be point A, which is representing 1, 2, point B representing 3, 5, point D representing 3, 5, point C representing x, 6, point B representing 4, y. We all know that diagonal of a parallelogram bisect each other. Therefore, the coordinate of the midpoint of AC will be equal to the coordinate of the midpoint of BD. So I'll mention that the diagonals of a parallelogram bisect each other. Therefore, coordinate of midpoints of AC will be equal to coordinate of midpoint of BD. So I can equate them using the midpoint formula. So 1 plus x divided by 2, 2 plus 6 divided by 2 will be equal to 3 plus 4 divided by 2, 5 plus y divided by 2. I can equate. On comparing, I can equate the x coordinate. 1 plus x by 2 will be equal to 7 by 2, and 8 by 2 will be equal to 5 plus y by 2. So I get 1 plus x by 2. On cross multiplying, 2 and 2 will get cancelled. This is equal to 7. And here 8 will be equal to 5 plus y. Therefore, the value of x will be positive 6 and the value of y will be positive 3. Therefore, we have found the value of x as well as the value of y. Question number 7. Find the coordinates of a point A where AB is the diameter of a circle whose center is 2, minus 3 and the point B is 1, 4. If I have a circle, imagine that it's a circle and there's a diameter and the diameter is AB. The coordinate of B is given 1, 4. The coordinate of A, if I consider x, y, it has to be found. Center, I'll represent it by O. The coordinate is 2, minus 3. We all know that the center O 2, minus 3 is the midpoint of diameter AB. Therefore, the center 2, minus 3 can be equated to the midpoint. I have considered x as x coordinate of point A and y as the y coordinate of point A. So x plus 1 divided by 2, y plus 4 divided by 2. On comparing, we get x plus 1 by 2 equal to 2 and y plus 4 by 2 equal to 3. This implies x plus 1 will be equal to 4 and y plus 4 will be equal to 6. Therefore, the value of x is positive 3 and the value of y is, here I have made a mistake. Can you identify this is negative 3? So it becomes negative 6 and the value becomes negative 10. Therefore, the coordinates of point A is 3, minus 10. Question number 8. If A and B are minus 2, minus 2 and 2, minus 4 respectively, find the coordinates of point P such that AP is 3 by 7 times AB. It means that the ratio AP is to AB will be 3 is to 7 and point P lies on the line segment AB. Here it is given that AP is 3 by 7 times AB. This implies AP is to AB is 3 is to 4. It is something like this. There is a line segment AB. The point A is minus 2, minus 2. Point B is 2, minus 4. And there is a point P which is dividing in the ratio 3 is to 4. Because if AP is to AB is 3 is to 4, BP is to AB will be equal to 3 is to 7. This will be equal to 4 is to 7. Therefore, the ratio AP is to PB will be equal to 3 is to 4. The sum AP added to PB will be AB, which is 7. Therefore, the ratio AP is to PB is 3 is to 4. Let us use the section formula. The coordinate of point P is 3 multiplied to 2 plus 4 multiplied to negative 2 divided by 3 plus 4, comma 3 multiplied to negative 4 plus 4 multiplied to negative 3 divided by 3 plus 4. On further simplification, we get negative 2 by 7, comma 20, negative 20 by 7. Hence, coordinate of point P is negative 2 by 7, comma minus 20 by 7. Question number 9. Find the coordinates of points which divide the line segment AB into 4 equal parts. In one of the question there was trisection, here it is quadrisection, which means 4 equal parts. So if 4 equal parts are to be made, I need to have 3 points. Remember that if I consider the line segment AB, say A minus 2 comma 2, B 2 comma 8, if I want to have 4 equal parts, there are 3 points which makes 4 parts equal. So each part will be 1:1:1. So if I mention 3 points here, P, Q, R, AP is to PQ will be 1:1, PQ is to QR will be 1:1, QR is to RB will be 1:1. Therefore, if I consider point P with respect to point P, AP is to PB will be 1:3. So the coordinate of point P can be found. So how do we find the coordinate of point P? This will be 1 multiplied to 2 plus 3 multiplied to negative 2 divided by 1 plus 3, comma 1 multiplied to 8, sorry 2 multiplied to 8 plus 3 multiplied to 2 divided by 1 plus 3, it's 1 multiplied to 8. So the coordinate will be minus 4 by 4, comma 14 by 4. Further simplification, we get negative 1 comma 7 by 2. This is the coordinate of point P. Similarly, we have to find the coordinate of point Q. To find that, I'll consider the ratio AQ is to QB. The ratio AQ is to QB will be 2:2. So the coordinate of point Q is given by 2 multiplied to 2 plus 2 multiplied to negative 2 divided by 2 plus 2, comma 2 multiplied to 8 plus 2 multiplied to 2 divided by 2 plus 2. So the coordinate will be 0 by 4, comma 20 upon 4, and further simplification we get it as 0, comma 5. Now to find the coordinate of R, I need to consider AR is to RB. This will be equal to 3:1. Therefore, the coordinate of R is given by 3 multiplied to 2 plus 1 multiplied to negative 2 divided by 3 plus 1, comma 3 multiplied to 8 plus 1 multiplied to 2 divided by 3 plus 1. So the coordinate will be 4 by 4, comma 26 by 4, which is nothing but 1, comma 13 by 2. Hence the coordinate of point P is negative 1, comma 7 by 2. Coordinate of point Q will be 0, comma 5, and the coordinate of R will be 1, 13 by 2, which divides the line segment AB in the 4 equal parts. Let us solve the last question. Question number 10. Find the area of a rhombus if its vertices are 3, 0, 4, 5, -1, 4, and -2, -1 taken in order. They have also given the hint that area of rhombus is half the product of the diagonals. So I need to find out the diagonals. If I consider ABCD as a rhombus, suppose if it is a rhombus, A is 3, 0, B is 4, 5, C -1, 4, and D -2, -1. Here the diagonals are AC and BD. So I need to find the diagonal AC. Using distance formula, AC will be -1 -3 whole square plus 4 -0 whole square, which is nothing but root 16 plus 16, which is root 32. This will be equal to 16 times 2, so 4 root 2. Diagonal BD will be equal to under root -2 -4 whole square plus -1 -5 whole square. This will be root 36 plus 36, which is root 72. We know 36 multiplied 2 is 72, so 6 root 2. Hence we have found the length of the diagonals. Therefore, area of rhombus will be equal to half multiplied to the product of the diagonals AC into BD. So it is half multiplied to 4 root 2 multiplied to 6 root 2. Here root 2 into root 2 becomes 2, and this 2 with the denominator 2 get cancels. We get it as 24 square units. With this, I'll end today's session. In the next session, we shall see exercise 7.3. It's all about area of the triangle. That's all for today's session. Thank you.